Hi Calculus, happy Friday. Thank you for your patience with me. I try to get the videos out the best I can. I'm not an expert filmmaker, as you can imagine, so it's always a bit of an adventure if I have to do it over or the technology gives out on me. But hopefully we're going to be good to go on this one. So let me just preface 5.1 with saying that this will be the last section on test 3, and I will talk about test 3 next week. So please don't send me a bunch of emails. When I get so backlogged with the emails, I just stop responding. So I will, and I will try to get caught up with the emails. I know a lot of you have asked me questions. When you have over 100 students, you can't believe the amount of emails you get. I can't even describe it. So I'll talk more about the test, and after I discuss it, if nothing's clear, then please feel free to email me if I didn't say something clear or you need more clarification. But please just give me a chance to put it in detail before I start to get a bunch of emails. Okay, so this is the last section on the test. This is antiderivatives, and the antiderivative is the opposite of integration. It's the opposite of integration. So I want to explain something really important to you, and I know I'm starting here with a derivative, but this is a really important concept to sort of wrap your brain around. When you take the derivative of something, functions in the same family will give you the same derivative, right? Functions that we are in the same family will give you the same derivative. So when we try to do the opposite, and I know this is going to look weird, but this is the opposite. This is called the antiderivative, and the verb is integration. I'm doing the integration, right? That's the action. When you do the integration, it's going to actually equal to x squared. I'll show you how to do that. And you have to actually write a plus c, because when you go backwards, the integration, unless we're given more information, doesn't actually know which specific member of the family this is, so to speak. So this is as far as we can go. This, by the way, is called an indefinite integral. And this won't make much sense now, and it's because there's not what we call limits. There's not little numbers here and here, which we call limits. That's a definite integral. So we're going to start doing what we would call indefinite integrals. Let me explain one other thing. This probably looks really bizarre to you, and that's fine. But I want you to think about this sign, which means integration. I want you to think about this sign and this sign. They go together. They're like a Batman and Robin team. This just basically says that I'm integrating in respect to x. And as you go up the ladder of mathematics, this can get really complicated. We're not going to do this, but let me just give you a for instance. As you go up the level in mathematics, you have to be able to be clear on which variable you're integrating over. If you're integrating over dx, then x is a variable and y and z are constants. If you're integrating over y, then y is the variable and x and z are constants. So this little guy at the end is really important because it tells you who the variable is. And as you get higher up in mathematics, the variable in which you're integrating in respect to can change. Okay, don't overthink that. Don't get all weirded out. I just want you to know that these go together so that when you integrate, they both go away. They're a Batman and Robin team. So I wish I was able to give you the packet because I feel like this helps you a lot. So let me just see if there's anything here in this beginning part that I would have stressed to you, and I'll try to keep it. Okay, I want to stress this a little bit, and feel free to stop the video and look at this after I say a few words. When we start integration, you know all the derivatives here, okay? So integration means you're going to do the opposite, right? The opposite. So it's like Jeopardy. It's like Jeopardy. I hope I'm getting the game right. It's like, okay, if you know the answer is secant squared, who made it? Right? We're going the other way. If the answer is secant squared, who made it? And you go, oh, that's tangent. Right? If the answer is secant tangent, then who made it? Oh, that's secant. Right? So it's like this, so just sort of like go backwards in your mind with all the trig that you know. So like the derivative of cotangent is negative cosecant squared. Oh, this is going to get a little confusing because the negative will be on the other side. But so then the integration of cosecant squared will be negative cotangent. And so like if the derivative of logarithm is 1 over x, then the integration of logarithm is the log. So again, you may want to just pause this for a second and wrap your brain around what the opposite is if you go in the opposite direction. Okay? I'm going to end this video here and I'll pick up again on another video. Catch you again soon. Bye-bye.